Hello everyone, welcome back. So in this video, we'll obtain the stationary point of a multivariable function. So we'll consider a two variable function, and this function is popularly known as Rosenbrock function, and for this function we'll obtain the stationary point, and then we'll also evaluate whether the stationary point is a minimum point or a maximum point or neither minimum nor maximum point. So let us go to the function. So this is the function, and it is a two variable function, the function of x and function of y, and the function is 100 into y minus x square whole square plus 1 minus x whole square. And as I said, the function is known as Rosenbrock function. And for this function, we need to calculate the stationary points. Okay, now what is stationary point? So in case of multivariable function, that gradient with respect to the variable should be equal to 0. That means del f is 0, and you will take the partial derivative with respect to x and partial derivative with respect to y will set to 0, and the point we are obtaining, that point will be the stationary point of this particular function. So now if I take the derivative of the function, so now if I take the derivative of the function, so this is the function, and if I take derivative with respect to x, so what I am getting? I am getting minus 400x y minus x square minus 2 into y minus x. So this is the derivative with respect to x, and if you take the derivative with respect to y, then you will be getting 200 y minus x square. So now take the second equation, that means this equation. So and this fy should be equal to 0, and from here, so I can write that y equal to x squared. So now take the first equation, that is the fx equation, and here you put y equal to x squared. So here I am putting, in place of y I am putting x squared, and then this part will be 0, and I am only getting minus 2 into 1 minus x. So I am getting this, and if I solve it, so I am getting x star equal to 1. So now put the value of x in this equation. So from here you can obtain that y is equal to 1. So that means stationary point of this particular function is 1, 1. So now we need to evaluate whether this stationary point is a minimum point, a maximum point, or neither minimum nor maximum. So for that, we'll calculate the Hessian matrix. So what is Hessian matrix? Hessian matrix is nothing but the second derivative of the function. So now let us calculate the Hessian matrix. So for that, I have to take the second derivative of the function. So this is fxx, that means del square f by del x square, and which is equal to minus 400y plus 1200 x square plus 2. And if you take the second derivative with respect to y, that is fxy, this is nothing but del square f by del x del y, and which is equal to minus 400x, and this is del square f by del y square. So I am getting 200, and this is the stationary point. At stationary point, so fxx is 802, fxy is minus 400, fyy is 200, and therefore the Hessian matrix is 802 minus 400 minus 400 200. So I got the Hessian matrix. Okay, so this is the Hessian matrix. So now what you have to do, you have to evaluate whether this Hessian matrix is a positive definite matrix or a negative definite matrix, or neither positive nor negative. So for that, what I can do, I can calculate the determinant. Okay, so determinant of h, and if I do that, so I am getting 400 as this value is positive. So therefore, this is a positive definite matrix. So in this case, the principal determinant, okay, so h02 is positive, and basically if I take the determinant of h, that is also positive. So therefore, this is a positive definite matrix, and hence the stationary point is a local minimum. Apart from that, what I can do, I can also calculate the eigenvalues of the matrix. Okay, so I can calculate the eigenvalues of the matrix. So using this equation, that determinate h minus lambda I equal to 0, and calculate the lambda. Lambda is the eigenvalues, and so what you will be getting, 802 minus lambda into 200 minus lambda minus 400 whole square. And if you are simplifying this equation, so you'll be getting lambda square minus 1002 lambda plus 400 equal to 0. So I'm getting this equation, and this is a quadratic equation. And if you are solving this equation for lambda, so you will be getting lambda equal to 1001.6 and zero point 0.4. Both the eigenvalues are positive here. Therefore, the Hessian matrix is a positive definite matrix. Okay. So, as the Hessian matrix is a positive definite matrix, so therefore, the stationary point, that is 1 1, stationary point is a local minimum. Okay. So, therefore, the stationary point is a local minimum. So, I hope the problem is clear to you. So you will also be able to solve similar problem. So what you have to do, basically, you take the gradient first derivative and equate to 0, and you will get the stationary point. Then in this case, as it is a multivariable problem, you obtain the Hessian matrix, check whether the Hessian matrix is a positive definite matrix or negative definite, and based on that, so you can tell whether the solution you have obtained, the stationary point you have obtained, is a minimum point, maximum point, or an or neither minimum nor maximum. So in this case, Hessian matrix is a positive definite matrix. Therefore, the stationary point obtained is a local minimum. Thank you very much.